All right, lesson 11. This is where we look at all the stuff we've already learned about electrochemical cells, and we start doing calculations about how long it needs to run, or if it runs for a certain amount with a certain amount of current or energy, how much of something are we going to either use up or produce. Okay. Now, in order to do this, there's three things that you need to be able to find or know, and that's where we're going to start first. So in the notes, you'll notice here there's the three spaces. The first one that you need to know is your Faraday's constant. Now that one is, if you ever forget it, you probably won't because you're going to use this a lot, but if by chance you ever forget it, it is in your data booklet. So if we go here back to page 3, you'll notice it right here. I guess I can just point right here, Faraday's constant. So 9.65 times 10 to the 4th coulombs per mole of electron. A coulomb is basically just a quantity of charge. It's kind of like saying I have a dozen chocolate bars or something along those lines. A coulomb is just a certain amount of our quantity of charge. It's an electrical term. Don't worry too much about understanding what that term means, but this just means for 1 coulomb, or there's 9.65 times 10 to the 4th coulombs, that much charge when 1 mole of electrons moves. Okay? So you need to make sure that you know that number. All right, let's go back to our redox table there. All right, and back to here. So let's write that number in our notes just so we have it. 9.65 times 10 to the 4th coulombs per mole of electrons. Okay. The next one is the amps to coulombs conversion. So amps is another electrical term or measurement that you need to know. So for example, the definition is that 1 amp is equal to 1 coulomb per 1 second. So that's what an amp is when you're talking about like a 15 amp breaker at your house. It means there's a certain amount, right? So let's use that as an example. If you have 15 amps, that means there are 15 coulombs moving past a point in the wire in 1 second. So whatever the amps are, it's just that many coulombs per second that are moving around. The half reaction ratio is going to come from our table. So depending on what metal you're talking about, so let's say for example you were doing iron right here. So if we were doing iron, the iron half reaction, I'm going to write it down here. Fe2 positive plus 2 electrons becomes Fe solid. Okay, now I'll show you. So I just wrote that down here so we can look at it. And let me get out of the way down here. Okay, so from that, what we're looking for is what's the ratio of electrons to solid. How many electrons need to move to create a solid? Okay, probably should have gone this way. That's a little better. I can doodle from over here. So in this case, that ratio is that it takes 2 moles of electrons, just taking that number from here, for every 1 mole of Fe solid. So I basically just took this number and put it here, and I took that number and put it there. Okay? So that's the basic gist of it. From here on out, it's just going to be using unit analysis to solve our problems. Okay? So let's do this. Let's get rid of those notes, but you've still got them on your page. Let's drop down and do some example questions. My advice here, and I would even write this in your notes somewhere, wherever it's going to stand out for you. Put a star by it. I would put always start with what you want. So whatever units you're trying to find, start with those units, and then we'll just work our way through and cancel out everything else. So for example, in the first question it says, how many grams of gold solid would be deposited by a 5 amp current in 2 hours? All right, so because I want grams of gold, I'm going to start with the molar mass of gold. So I have 196.97 grams per mole of AU, or gold. Now the grams, this unit right here, that's the unit I want to keep. I don't want to cancel that one out. It's what I want to end up with. But everything else has to go. So I need to get rid of moles of gold. So if we look up at your notes, look at the 3 things that we need to know. Which of those will help me cancel the moles of gold? Faraday's constant, amps to coulombs per second, or our half reaction. And the only one that has the actual metal in it is the half reaction. So if you look in your data booklet, look at the gold half reaction. It's pretty high up at positive 1.50 near the top. And according to that half reaction, there's 3 moles of electrons for every gold solid that's produced. So that means we can type that in here, and we want to, or not type it right, we want to cancel the gold. So the mole of gold is going to go on top this time, and I'm going to put the 3 moles of electrons on the bottom. So now this has canceled out. Now I need to get rid of the moles of electrons. And so I look back at the things I know, and the other one that has moles of electrons in it other than the half reaction is Faraday's constant. So I want the mole of electrons on top, so I'm going to flip that over and put 9.65 times 10 to the 4th coulombs on the bottom. So now the moles of electrons are gone. Now I got to get rid of coulombs. And the question gives me that it tells me that it's a 5 amp current. So I know that 5 amps is 5 coulombs per second. So now I can get rid of the coulombs. And it's in 2 hours. So I need to get rid of seconds first. So there's 3,600 seconds in an hour. And I'm running out of room here. And then there's 2 hours in the question. So if I look now, my seconds have canceled here, my hours have canceled here on the edge, and all of my units now have canceled except for the grams. So now I can calculate it out. Go ahead and give this a try on your calculator if you want to pause the video here. If you've done it right, you should end up with 24.5 grams of gold as your final answer. Okay, let's try another one. Number 2, how long must a 4 amp current run to produce 20.0 grams of Al solid from Al3 positive? Now this isn't really a great question because it doesn't specify the units. On a test, I would either specify the units in the question, or if you were to look down at either the multiple choice answers or the numerical response, they would all be listed as either seconds or hours or minutes or whatever. They would specify that somewhere in the question, even if it's in the answer. So look for that if you're unsure. I'm going to go ahead and specify this case I want hours. Okay. So I'm going to start with what I want. What I want in this case, I'll start over here so I have a little more room, is in 1 hour I know there are 3,600 seconds. Again, this is the unit this time that I want to keep. Everything else has to go. So I need to cancel seconds. Why did I put seconds in brackets? Fix that just because it's kind of annoying me. 1 hour, 3,600 seconds. All right. So I need to cancel seconds. The only other number that we've talked about that has seconds in it is my amps to coulombs per second conversion. So the question says that this is a 4 amp current, which means I have 4 coulombs per second, but I want the seconds on top so that they can cancel. So the 4 coulombs goes on the bottom. Now I have coulombs. I want to get rid of that. The only other number that has coulombs is Faraday's. 9.65 times 10 to the 4th coulombs per mole of electrons. Coulombs is gone. Now I got to get rid of moles of electrons. The only one that has that is half reaction. So I look at my data booklet. Aluminum is, where'd you go? Oh, way down here. Right there. So there's 3 moles of electrons for every aluminum solid. So we drop back here. 3 moles of electrons for every 1 mole of aluminum. Moles of electrons are gone. Now I've got to get rid of moles of aluminum, and the only other number that has that is molar mass. So for 1 mole of aluminum, that's going to cancel. I have a molar mass of 26.98 grams. Now I have grams that I need to cancel, and the question tells me right here that there's 20.0 grams is what they're wanting to know. So I can just use that number, and that will cancel that out. So again, all my units have canceled, and that leaves me with a final answer of, again, you can pause if you want to try this on your calculator just to make sure you're doing it right. But I get 14.9 hours. Okay, hopefully that's straightforward enough so far. Let's do one last example and then that'll be it. So this might be a little bit longer of a video, but we'll get it all into one. So let me clear this off. I'll drop down. This one's a little bit more complex because this one wants to know how many amps it takes to produce 10 grams of gold from gold 3 positive in 1 hour. None of my numbers directly have amps, but I do know that amps equals coulombs per second. So I'm going to actually have to start with 2 numbers with coulombs and seconds to try to cancel out. So for example, Faraday's has 9.65 times 10 to the 4th coulombs per mole of electrons. And I need to also have coulombs per second so that I can get that. That's what an amp is. So I'm also going to use, right off the bat, 1 hour, because that's the unit of time they used in the question, is 3,600. I did it again. Why am I doing that? Seconds. So here, instead of having 1 unit I want to keep and everything else has to cancel, in this case, I need to keep coulombs and I need to keep seconds on the bottom because that will give me amps if I end up with those 2 units in that arrangement in the end. Doesn't matter what you cancel out first though. So let's start with moles of electrons. I would use the only other number is the half reaction. So since this is gold, we've already learned this one from our reaction above, example number 1, that there's 3 moles of electrons for every 1 mole of gold. So now those are gone. But now I have a mole of gold. To get rid of that, I'm going to have to use molar mass, which is a mole of gold, which I want on top so it'll cancel, is 196.97 grams. I want to get rid of grams, so I put 10.0 grams from right here in the question. Now be a little bit careful because I've canceled everything starting with the moles of electrons and I followed that one through. I still have this unit right here of hours that I need to deal with. So don't forget about that one. So I still need to get rid of that question, that unit, sorry. Luckily in this one they gave me that right here in the question, that this is running for 1 hour, and I want to put that on the bottom. Now in this case, that's not going to change my answer at all. But don't shortcut that step. Get in that habit, because if they would have said 2 hours or 3.5 hours, that absolutely would change the question and the answer. So now I've canceled every unit. I can go through, they're all canceled out except for the coulombs per second. If you calculate that out, you get 4.08 coulombs per second, which is equal to 4.08 amps. And that's my answer. So that's it. Make sure you know those constants. Remember, Faraday's is in your data booklet, so if you ever happen to just short out your brain, you can go look that one up. The amps to coulombs is not, though. That's one you got to memorize. And the half reactions you can pull from your data table. After that, always start with what you want to begin with, and then it's just unit analysis. Cancel out everything until you're only left with whatever you want, and you should be good. All right? Hopefully that makes sense. Like I said, if you have any trouble, let me know.